Hey guys, and welcome back to my channel. For the past few months, I've been designing a invention which is based off of the Maglev train. So it's a Maglev bicycle where the wheels don't touch the chassis and the chassis is hovering. So how would this work? I made my first design. It had a circuit changer which changed the circuit to change the poles of the electromagnets over and over like a maglev train, but I decided that wasn't ideal for a maglev bike and it would be very power consuming. Iteration 2. Well, it was the same thing except it had a generator. When you would pedal, you generate power to charge the battery and it would last for longer. And I decided that since there was still a circuit changer involved, it wasn't ideal. So I made a third design. Now, this third design was based more on a normal bicycle, where the chain is turning the wheel, but in this case, the chain isn't directly connected to the wheel. Instead, it's an electromagnetic link which turns the wheel. And I decided that this would be ideal, but I need the chain on both sides. Because you see, it's hovering in the air. So pull on one side, there's still resistance on the other. And it could cause the wheel to curve slightly. And you'd be moving diagonally when you want to go straight. So I decided you need electromagnets on both sides and chains on both sides, rotating. And there was still a generator involved, a DC motor, which when spun by your movements on the pedal, it would recharge the battery. And now this design still had flaws. If you would pedal backwards, the bike would move backwards, and if you'd stop pedaling, that would act as brakes. And I didn't want that. So I implemented yet another thing from a normal bicycle into this. If you've ever moved a normal bicycle forwards, and you've probably heard a ticking sound. That ticking sound is a mechanism which slips when the chains are pulling it in the wrong direction. That's why you can't pedal backwards. And that slipping makes a clicking sound. So I decided I'd implement that into my design. So now you could only go forwards. Now I had to work on a better braking system. So now when you pull the brakes, you'd amplify the power to the electromagnets so that they wouldn't slip or grind. And then something would stop the gears from moving. And then that would in turn slow down and eventually stop the wheel. This is a very smooth braking method, but it's not very fast. So this bike is just a normal ride-around bike. And this wheel design could be implemented in cars, probably not trucks because they're too heavy, and other vehicles too. And you just need the right amount of electromagnetic force pushing on the wheel to make it not grind against the capsule itself. But now there was another problem. The capsule I'm talking about is connected to the main body of the bike, which has all of the batteries or supercapacitors if you'd like, and the generator, the pedal, and it's filled with electromagnets, all the same polarity. Those electromagnets push against the wheel, which has the same polarity as the capsule. So that pushes it out, but on the bottom, the capsule goes around the wheel like this, but not all the way down. So that'll push the wheel back up so it doesn't fly down out the bottom. So this makes the bike a lot safer, but it does bring up another problem. You need to power the wheel somehow. And you can't make a separate battery inside the wheel and charge the wheel every so often. That wouldn't work. So I went online and tried to research a good way to power it, connected to the actual bike, but not physically. And most of the methods I found were pretty dangerous. But then I remembered Apple watches, they charge wirelessly. Mercedes-Benz, they have a car that charges wirelessly. And I decided that I'd do some research on that. And I made a little circuit which does wireless transmission, and I decided that'd be ideal for transferring power into the wheel. And the wheel would in turn give a force which would cause the bike to hover, and the front wheel would not have a propulsion system, but would just simply make the front of the bike hover. And this capsule wouldn't be completely circular, for that would be a lack of suspension, but it'd be a little tall and slightly curved. Not a lot tall, like 2 inches, that's it. And on the top, there's greater electromagnetic force than on the sides and the bottom. That would create a suspension system built in, so when you bump, the wheel will move up further into the capsule, and then the greater force on top would push it back down, creating a smooth suspension system. And that's basically it. This would have 0 carbon emissions whatsoever, and hopefully this could change the world, and I really hope that someone looks into this design. Thank you.